All right. Okay, sorry, it took me a second to get the right screen. So we've moved on to 2.7. So we're going to be finding equations of lines. So previously we were given equations of a line and we gathered information about that, like its slope and its y-intercept. This time we're going backwards. So we're going to find the equation of a line when the slope and the y-intercept are given. And then we're going to find the equation of a line when a slope and a point is given. And then we're going to look at this with 2 points as well, and hopefully a little bit of application. So we're going to start here with a formula we've already used several times, slope-intercept equation, or as I had said, we can also call it slope-intercept form. So the slope-intercept form for the equation of a line with a slope of m and a y-intercept of b is y equals mx plus b. There is also another equation for a line, and this is another fairly common one. We'll be using both of these today. But this is point slope equation, or as I say, point slope form of the equation of a line. And it's going to once again have a slope of m and passes through a point x1, y1. So this one can be a little confusing at first. Add a little bit here. So right here is our equation. Y minus y1 equals m times x minus x1. Sorry, let me move that down just a little bit more. Bottom part wasn't fitting in. So what to note here is that those points x1, y1, so the ones with a subscript, those are going to have a numerical value to them, just like the m does. Those ones that the x and the y that don't have a subscript on them, those are going to be variables. Nothing is going to change about them. They're going to stay x and y. Okay. So we have this equation or this information here. A line has a slope of negative 3.2 and a y-intercept of 0.5. We want to find the equation of the line. So this is going to be your easy one because we have a slope and an intercept, which means we can use slope-intercept form. So we know that this is my m is the negative 3.2. This is my y-intercept. So x is 0, y is 5. So I intercept at 5, which means my b is 5. So if I have a line with a slope of negative 3.2 that has a y-intercept of 5, well, the equation for that line is simply going to be y equals negative 3.2x plus 5. So here's where things are going to get a little more difficult. So we want to find the equation of a line with a slope of 3 that contains the point 2, 7. So this point, we don't have a 0 here, so this is not a y-intercept because I didn't need an and. But we do have a slope. And we have a point. So remember, if we had a point, x1, y1, and we had a slope of 3, well, we can use this. So this was called our point slope form. And what it said is y minus y1 equals m x minus x1. So this is still the equation of a line. We just need to fill it in. So as we said over here, slope is 3. We have a pair of points, an x and a y. So we're going to say that x1 is the 2 and that y1 is the 7. So like I said, x1 and y1, we would have numerical components for it, and they come from that point that we are provided. Like I said, just remember it's an xy pair. We're just calling them x1 pair, x1, y1 pair. So if I fill in my formula here, I'm going to have y minus y1, which was 7, equals m, which is 3, times x minus x1, which was 2. So technically right here, we do have an equation. oops, equation of the line. This is typically not how we like to show lines. So we're going to just add a little bit here. So unfortunately, I'm going to have to take some of this over here. So I'm going to make this little box here. So what we want to do is we want to have an equation in slope-intercept form. So to do that, what we're going to do is we are going to take this equation and solve for y. So y minus 7 equals 3x minus 2. So probably the easiest way to do this would first be to distribute our slope here. So we're going to have y minus 7 equals 3x minus 6. Then all we have to do is just add that 7 so we can isolate that y. And we get y is equal to 3x plus 1. And I would always suggest that when you do this, just check. So we know that this point is supposed to fit in there. So what we're going to do is I'm just going to replace my x with the 2 and see if I get a 7 back. Okay. So that was just me checking. Yes, we have the right equation. So as I said, this is technically a correct equation. We just have a tendency to like to have these in slope-intercept form. So the equation for a line with a slope of 3 that contains the point 0.27 could be the line y minus 7 equals 3 times x minus 2, or it could be y equals 3x plus 1. So take a moment at this point to pause the video, and I'd like you to try on your own to work on worksheet problems 1, 2, and 3. All right, so let's start with this first one here. So we want to find the equation of a line that has a slope of 3, and it has the point, and contains or passes through the point 4 minus 4. So my slope here is the minus 3, that's my m. This is going to be my x1 and my y1. So y minus y1 equals mx minus x1. So we said that y was the minus 4, so we're going to have, or so the y1 was minus 4, so we're going to have y minus minus 4. Then we said slope was minus 3, and then we're going to have x minus x1, and x1 was just positive 4, so it's just x minus 4. All right. So like I said, technically that could be the equation of a line. Oops, I can't spell. We're going to do this for practice. Once again, we're going to solve for y, just so we can get that slope-intercept form that we like. So y minus minus 4 is y plus 4. If I distribute this negative 3 across, I'm going to get a negative 3x minus 3 times minus 4 plus 12. Subtract 4 from both sides. I get y equals negative 3x plus 8. And like I said, you can put the point back in. So if we put 4 back in, minus 3 times 4, that is going to be a minus 12 plus 8. It's going to leave me with a negative 4. Like I said, it's always best to go back and check to make sure this point had actually worked. And that is going to be the equation for a line. So y equals 3x plus 8. So this one, we are going to have a different kind of slope. We're going to have a fractional slope. So we're going to find the equation of a line. And this time the slope is going to be 1/3, and it contains the point -6, 1. So my x1 would be -6, and my y1 will be 1. So this is my point slope form again. Can never get those right. So y minus y1, so y minus 1 times 1/3 minus x1, which was -6, so minus 6, or you could just said +6. We'll keep going and solve for y. So if you want to, you might want to do this little extra step here where you could change this to x plus 6. So we got y minus 1, and then we'll distribute this 1/3. So we'll have 1/3 times x, and then 1/3 times 6. It's going to leave me 6/3. So 1/3 x plus 2. Add 1 to both sides, and we're going to get y equals 1/3 x plus 3. Once again, if you just want to kind of quickly check, if we put -6 in, 1/3 of -6 is going to be a -2 plus 3 would give me a +1. So this point would still works in the line. And hopefully this one wasn't too confusing. So we want to find the equation of a line with now a slope of 5 that contains the point 2, 0. So the 0, notice that's in the y position. This is an x-intercept. This is not a y-intercept. So because it is a x-intercept, we are going to still use our point slope form. So we can only really use that, well, not completely true, but it's easier to use that slope intercept form if we have a y-intercept. I don't have a y-intercept here, so it's actually easier to go about and use the point slope form. So I'm not going to label your points this time. So we have y minus, what would be y1? Well, it'd have to be that 0. What's my m? Well, it's the slope of 5. And we have x minus x1. My x1 is that 2. So we end up with y equals 5 times x minus 2. If you want to, you can distribute that 5, and we get y is equal to 5x minus 10.